When Pluto was reclassified as a dwarf planet in 2006, most wrote it off as nothing more than a cold, dead rock floating on the fringe of our solar system. But recently declassified images from the James Webb Space Telescope have quite dramatically changed that view. These striking pictures not just invalidate our perceptions but offer up a chilling new picture of Pluto, one that's vastly more subtle and potentially far more uncu. Perhaps the icy surface we thought we knew so well as being inactive and untroubled actually harbors secrets truly mysterious. What hidden mysteries simmer below Pluto's ice crust, and how would that alter our whole understanding of our solar backyard? At the center of Pluto's secrets is its most iconic landmark, a giant heart-shaped ice glacier called Sputnik Planitia. This enormous area is so dominant it has actually changed Pluto's orientation in space. But what's hidden under this glacier has scientists interested and worried. Underneath the heavy nitrogen ice could be a hidden ocean of liquid water warmed by the heat from inside the planet. This is not a frozen desert, it's an energetic, churning landscape. It moves with convection currents like a frozen lava lamp. What powers this internal warmth? Probably radioactive heat from Pluto's core keeps the ocean in spite of Pluto's extreme distance from the sun. But the meaning of this find goes deeper than that. If there is water, could there be life in this extraterrestrial sea? Too far from being lifeless. Pluto is turning out to be a geologically active planet. High-resolution images show widespread tectonic fractures and fault lines on its crust, obvious evidence of internal activity. Such activity is surprising for a planet so distant from solar heat. Even more intriguing is the way in which Pluto's enormous glacier seems to affect its alignment with Charon, its biggest moon, in a gravitational interaction that seems to dance according to some weird rhythm of its own. Such phenomena raise disquing questions about what forces are powering such energy and whether there is something mysterious hiding beneath the ice. The presence of a liquid ocean on Pluto is not just a scientific curiosity, it's a revelation. Water is necessary for life as we know it. Discovering it here, trapped under ice and cut off from sunlight, broadens our knowledge of where life could be found. Pluto's hidden subsurface ocean, trapped in perpetual darkness and shielded by miles of ice, may support forms of life stranger than anything we have ever found. Life here would have to adapt to a harsh, otherworldly environment. According to physicist Brian Cox, even the simplest forms of microbial life on Pluto could revolutionize our understanding of biology and our place in the universe. But what if life under Pluto's surface isn't just possible? Its dangerous thermal signatures and strange chemical markers picked up by the James Webb Telescope suggest something more may be happening beneath the surface. Some of the anomalies resemble patterns associated with biological processes. Could they be the remnants of microbial life or proof of something more complex, more advanced, and perhaps dangerous? The notion that life might exist under such extreme conditions isn't merely intriguing, it's profoundly disturbing. Is Pluto possibly home to some kind of life so foreign that it defies our own understanding of what constitutes life? Pluto's subsurface ocean could have been created through violent origins. Theorists among researchers propose that Pluto formed quickly with violent collisions, warming up the native planet so much that a deep buried sea was formed. Radioactive decay has kept the ocean from freezing over the centuries, but such an origin may imply that Pluto has been a planet of extremes from the very start, produced by fire, shrouded by ice, and now energized by potential. Might it be that this tumultuous birth also swayed the seeds for life or for phenomena yet to be revealed? Pluto is more than a survivor from the Kuiper Belt. She is a dynamic, evolving planet, and it's not merely the surface or interior that defies anticipation. The dwarf planet also features a thin yet multifaceted atmosphere disclosed in breathtaking clarity by the James Webb Telescope, made up largely of nitrogen with traces of carbon monoxide and methane. This thin layer of atmosphere radiates a reddish color due to organic molecules known as tholins. These molecules result from sunlight-initiated chemical processes and could be the precursors to more complex organic chemistry. Are they possibly building blocks of life in harsh environments? Pluto is not alone. It has a big moon, Charon, that is responsible for much of Pluto's behavior. The two are gravitational companions in an unusual binary system. Charon itself displays tectonic activity, deep grooves, and an enigmatic red polar cap, possibly produced by gases being released from Pluto and freezing upon its surface. This peculiar interaction implies a very intimate relationship between these two planets might share and be impacting geological or even biological processes within Pluto, and what could possibly be hidden within this binary system that challenges our conception of moons and planets. Whereas the Kuiper Belt is packed with icy remnants of solar system formation, Pluto is different, where its inactive neighbors are quiet, and still Pluto is alive with activity, creeping glacier, evolving atmospheres, and geothermal heat. These findings suggest that other apparently lifeless objects in the outer solar system might similarly contain hidden complex systems within their ice shells. Pluto itself might serve as a doorway into a secret dynamic universe outside Neptune, a whole world of unsuspected science and potentially life. The James Webb Telescope's revelations have opened Pluto's new frontier, but with them comes an enormous list of new questions. To unlock Pluto's true nature, we'll need future missions that go far beyond the 2015 New Horizons flyby. These expeditions must probe its icy crust, explore the chemical complexity of its atmosphere, and dive deep into its possible ocean. As our technology evolves, so too does our ability to peel back the layers of this distant world. Would Pluto assist in answering some of the universe's most fundamental questions regarding life, planetary formation, and the outer reaches of our solar system? One of the questions that have gone mostly uninvestigated is whether Pluto has a magnetic field. Although proof is indirect, data anomalies suggest magnetic activity hidden beneath its surface. On our planet, our magnetic field protects us from harmful radiation and maintains the atmosphere in balance. Could Pluto have a similar system, shielding its inner ocean and delicate atmosphere from the cold, unforgiving emptiness? If so, it could help explain the planet's bizarre heat signatures and geologically active surface, and provide insight into how icy distant planets can be so surprisingly vibrant. Pluto resides at the outer reaches of our solar system, where gravity, radiation, and other forces operate differently. Charon's gravitational pull and that of surrounding Kuiper Belt objects could be propelling some of the internal heat and tectonic activity. These recurring gravitational nudges might provide enough energy to power current processes beneath the surface of Pluto. It's even conceivable that Pluto had previous collisions that remolded its surface and initiated long-term geological consequences still unfolding today. What was once a distant, lifeless world is now a cosmic marvel. The discoveries of the James Webb Telescope have dispelled past misconceptions and revealed a world teeming with energy, enigma, and promise, with flowing glacier, enigmatic chemistry, a potentially active ocean, and an atmosphere unlike any other. Pluto has become one of the most fascinating bodies in our solar system. It compels us to redefine what planets are and where life may germinate. The question is no longer whether Pluto might support life, but what that life might look like and what it might indicate about the study of biology, evolution, and the universe. Is its subsurface ocean a habitat for bizarre, thriving life forms? What do its tectonic activity and chemical signatures say about exoplanetary systems, and what other secrets lie hidden in the Kuiper Belt's icy twilight? Pluto is more than just an old relic today. It's a call to the future. As our technology advances and our missions take us further, we are one step closer to learning the secrets of this mysterious world. What do you believe Pluto is keeping hidden behind its icy exterior? Let your dreams run wild and continue to gaze at the stars. The road to knowing Pluto has just started, but one thing is sure: in this cold, remote universe, a new frontier of discovery awaits.